much for the introduction. I'm Manuela Uliano, a research fellow at the Robotic Institute of Sant'Anna School of Advanced Studies in Italy. And within the European ModelHRI project, our team of researchers is working on the development of a high-level grasp library with the aim of giving the robot autonomy in the grasp choice of flexible and deformable materials and objects in an industrial context. Today, I will briefly present our idea of grasp library with the hope of creating interest in you and exploring the topic more in detail in the future with those interested. The grasp library receives as input the symbolic description of the current situation, and based on this description, the grasp library defines how the robot has to grasp the object in order to successfully complete the subsequent task. The grasp library will, at the end of this process, the grasp library will describe the grasp action by means of 3 indicators: the grasp type, the grasp location, and the grasp dimension. According to the kinematic constraints of the gripper, the grasp type is chosen among those contained in a taxonomy that we are considering as a reference. Then the grasp location is an area of the object that interacts with the hand during the grasp. The grasp location is chosen among the object locations that are defined according to the local geometries of the object and the size of the hand that has to interact with it. Finally, the grasp dimension is the axis of the object that lies between the fingers during the grasp. I would like to focus your attention on the decision-making process of the grasp library. That it is based on the application of a series of rules that model the human behavior in the grasp choice. We decided to model human behavior because of 3 main reasons. The experience gained by humans over the years made their grasp strategy super efficient. Then the production lines and objects are designed to interact with humans, and in the case of handling over an object, if a robot passer behaves like humans, the human-robot collaboration results more efficient and the human experience and perception improves. So the tables in the slide show the rules on which the grasp library is based. And by means of these rules, the grasp library decides which is the best combination of grasp type, grasp location, and grasp dimension. I will report just 2 rules by means of examples that model human behavior in the selection of the grasp location. In the following, the object to manipulate is an insole. And we can find 3 different object locations: tip, body, and heel. From the description of the current situation, the robot knows which is the task to be performed. And in particular, in this example, the robot has to grasp the insole and pass it to a human operator. And then the human operator has to insert the insole inside the bag. The task can be constrained or not constrained. For us, a task is constrained if a particular object location has to interact with the bag first. In this case, we will call this location use location. So, in line with this, we can say that if the task is constrained, the robot selects as object as a grasp location the use location in order to facilitate the grasping for the receiver and also the execution of the subsequent task for the receiver. Otherwise, if the task is not constrained, the robot selects as grasp location the object location at the extremities of the object in order to facilitate the grasp action for the receiver. A task-oriented grasp reduce the number of object manipulations for the receiver after the handover, increasing the performance of the subsequent task and improving the perception of the interaction. The second rule that I reported comes from an ongoing study that our team is carrying out. And we assume that in the case of a constrained task, the distance between the grasp location and the use location decreases as the degree of deformability of the object or the precision of the task increases. In this case, the robot has to directly insert the insert inside the bag. In line with our hypothesis, if the task is constrained and the object is deformable, the robot selects as grasp location the object location near to the use location, that in our example is the use location. So the robot has to select the body location. I reported just two examples, but I can say that each rule is based on one of the main factors that influence the grasp choice. For instance, the object the physical characteristic of the objects, or the constraint imposed by the task or by the environment. However, the literature doesn't show a clear consensus on which factors play the most important role in the grasp choice. So we are currently wondering which the weight that humans give to different factors is, and consequently, how could we manage the rules prioritization? Thank you for your kind attention, and I hope that the topic was of interest for you.
Thank you, Manuela. Thank you. We have time for one quick question, and the rest goes in the chat or in the Miro board. Maybe I'll ask my question, which is more, I guess, of a suggestion in regards to one of your open issues. So wouldn't you be able to learn different rules? Well, let's say how different factors influence the grasp choice if you just collect a lot of data from human grasping? So, for instance, you could use some kind of machine learning methods.
No, sorry. So finding the appropriate grasp strategy is a challenging task, because there is an infinite set of candidates, and so there are a lot of approaches like learning the learning one. But we decided to follow a semantical approach because we want to base our approach on a known approach, and the learning one is like a black box, for instance. So we decided to follow this approach.
Okay, good. Thank you. Thank you, Manuela.